Now let's take a look at what we're going to call a library of functions. The idea is that we want to get comfortable with a few very common and basic functions. These functions are going to be the starting point for developing more complicated functions. So the better we understand these graphs and these functions, the better will they be able to understand more complicated ones. All right, so the first type of function we're going to look at is the linear function. Now this should not be a surprise at all, because a linear function, f of x equals mx plus b, looks just like the thing we were talking about as a line. So y equals mx plus b. It's just we're treating it as a function now instead of just simply a graph. So that's the only difference here. Instead of calling it y, we're calling it f of x. It's still, any linear function is going to have the basic shape like this. All right, so just the line. The only difference, again, is that we're calling it by a function. Now, there are a couple of important subcases here. The identity function is f of x equals x. So that's the equivalent of y equals x. So that's the reason this one is so important is because when you plug in x, you're getting x out. So it's the very important function where what you plug in is what you get out. So that's a very important one that we'll see a lot. The constant function is just when you plug in any x, you get the same constant. That was a y equals k line that we had before. And in this case, we're just saying that when you plug in any x into the function, you always get the constant k. Notice that the only line that we're not looking at here is a vertical line. But a vertical line is not a function because you have infinitely many values for one x, and that's not a function, y of x. All right. So what might we make of this example? Write and graph a linear function with f of negative 2 equals 2 and f of 2 equals 4. So we want to come up with a specific linear function that gives us these values when we plug in negative 2 and 2. But let's notice something. When you say f of negative 2 is 2, you mean that when you plug in negative 2, you get the value 2. Or in other words, if you were talking in a graph, you'd be talking about this saying you have the point x of negative 2, y of 2. And similarly, for f of 2 equals 4, you'd be saying, oh, you have the point 2, 4. So this entire problem is really the same as find the equation of the line through negative 2, 2 and 2, 4. We did that when we were doing lines. The only difference here is in the end we want to call it f of x and not y. So let's see. If we want to do this, we would first have to find the slope, which would be 4 minus 2, the y value here minus the y value there, over 2 minus negative 2. So that would give us 2 over 4, and that gives us 1/2. All right. So we need, anytime we want a line, we need a slope and a point on the line. We have 2 points on the line. I'll go ahead and use my 2, 4 point, and I would just say y minus the y0 of 4 equals m 1/2 x minus the x0 of 2. That would give me y minus 4 is 1/2 x minus 1 when I distribute that 1/2. That gives me y equals 1/2 x, and then adding over the 4 gives me a -1 plus 4, or plus 3. Okay, so that would be the line, that would be the equation version. So now all we do is say the function would be f of x equals 1/2 x plus 3. There we go. There's our linear function that satisfies those two function values. So those were the linear functions in general. Now let's take a look at some more very specific functions. The squaring function, f of x equals x squared, is very important. We want to know what the basic graph of that looks like. So right now I'm talking about just basic sketches of the graph. So if I just wanted to know what the basic picture looks like, it looks something like this. All right. Now obviously that doesn't have any points shown on it, but I know that if I really did want to say, oh, let's think about a point on here, I could plug in a value, say 2, and I know that when I plug in 2 to x squared, I get 4, so I would know I could always find the point, points such as 2, 4 on it. How about the cubing function? So this one looks like this. Okay, and again, that's the basic shape of it. And if I wanted to, find a point, I could do something like, oh, let's take -1, plug in -1 into x cubed, and you actually get -1 back. So there's your point, -1, -1 on the graph. If I wanted, I could plug in anything else I wanted as well. How about the square root function? Well, the square root function looks like this. All right, and it's actually half of what would be x equals y squared, the graph x equals y squared, but that's not a function y of x. So it does look a lot like the parabola that we get when we do x squared, except it's on its side and it's only 1/2 of it, the top half of it. All right, again, let's see, if I wanted to put in some point, I could put in maybe 4, and that obviously would be 2, and so I could say I have the point 4, 2 there. How about the cube root function? Well, the cube root function looks like a twisted version of the cube function. So it is like this. Okay. And here, if I wanted to, I could say, oh, if I put in, say, 8, then I get 2. So there's the point 8, 2. So there's just an example of a point on that graph. What about another one? The absolute value function is an important one. And that has this very characteristic V shape. And the absolute value of x is got that little corner there at the origin. So it's a straight line. It's like y equals x in the first quadrant there, and it's like y equals -x in the second quadrant there. So it is actually just a v there, and we'll see later on how we can manipulate that. So these are the functions that we want to be, and graphs that we want to be familiar with. Back from the linear function and lines, the squaring function, cubing function, square root function, cube root function, and absolute value function. Those are going to form the basis of our functions. So those are going to be the ones that we build off of to make our more complicated ones.